Hello class, I'm going to go ahead and go over the version of the MyLabs Plus test number 4 review that was generated for me, and that way it could possibly help you with your studying as you get ready for test number 4 for our liberal arts math class. Okay, so if you look at problem number 1, so I can increase that. It says explain how to distinguish between a permutation and a combination problem. And then you have these answers to choose. And so, some of your problems are going to be applications that involve either, the combination or the permutation. They're going to be applications. And so oftentimes what helps me think about the definition for when order is important in an item is permutation, and I think of it as opposite of a combination. You would think that in a combination, right? Combination lock. You have a combination lock for like your high school lockers, remember, or gym lockers. So you have a combination lock, and you would think, yeah, combination order is important for the combination lock. But when they created the naming for these situations, they actually didn't intend for the combination to be that definition. It's the permutation. So just think of it as opposite, contrary to what you would normally think. And so I know normally you think in a combination lock the order is important, but remember for this subject and these applications, it's contrary, it's the opposite. So it's the permutation. So I hope that will help you remember that. And that's usually what I kind of think of to help me remember this. And so for us in our choices, it'll be answer D then. Permutation problems involve situations in which order matters, and combination problems involve situations in which the order of the items makes no difference. Okay, and so in your Canvas assignment where you upload your test review, I have a formula sheet for test number 4, and I also went ahead and made a vocabulary chart, or a PDF of a vocabulary chart that if you like, you can print that and use it. And I don't think you need all those charts. It's basically the same chart. So I think one printout would be fine. And so I'm going to show you what I'm talking about. Let's see, let me show you this. It's called the 3 counting methods. And I did go ahead and put one also in your test 4 module where you have your save PDF notes, but I also put one when you upload your test review. Yeah, so they're very similar. It's a very similar chart, but then and this is from one of the recordings in your videos. And so it says here the 3 counting methods. So this is for the fundamental counting principle. That's what FCP stands for, fundamental counting principle, permutation, combination. Okay, and it does say that the order of categories, when the order is important, that you could use the fundamental counting principle, or the permutation requires that order is important. Okay, and notice how it's blank here, so that you don't want to try to use combination if order is important. That's out of the picture. And so that's why here for order not important, that's why they have combination. Okay, and then sometimes repetition is needed, repetition is allowed. So this is saying that in the fundamental counting principle, repetition is allowed. It will also sometimes repetition also may not be allowed sometimes in the fundamental counting principle as well. So you could have a couple of situations where that would happen. Okay, either situation would be acceptable. But then here for permutation, it says it's required repetition not be allowed. Okay. whereas combination, repetition, not be allowed, also required. So this chart might be helpful as you if you have it out, and depending on your problems that you look at. And so in the sheet, they were emphasizing, I think this is probably the best one because of the wording. It says no repetition, order important, and all objects use NPR, and that's for your permutation, okay, or in factorial, okay. The others, let's see, it's the same chart, but then they highlight repetition allowed and order important, that you must use fundamental counting principle. So repetition allowed, okay. So this would be an example. It does say, okay, repetition allowed and order important. Okay, you must use FCP. So that's just one variation, but you can get that off of reading the chart, okay? So if you want to choose one to print out, I think this one might be the best one. Let's see what this one says here. So this says no repetition and order important. Use the fundamental counting principle or use this NPR permutation. So again, I think that that is also picked up here in this table as well. Required. So these are just same markings here. Okay, so I think if you have to just print one sheet, I think I would probably choose this one, because these these red items here at the bottom that are here, you can assume that or gather that from the chart. Okay, so I think if I were just to print one table, it probably would be this one to use while you're taking the test. Okay, so keep that in mind. The other thing that you might want to have are these keywords. Okay, and again, if you don't have a printer, you could write these down on a sheet of paper or write it down on your test review. Okay, so here we have keywords. This is order when order is important, or there are categories is when you're working with arrangements, when you're working on the election of officers, order is important. Because normally a person cannot hold several offices at the same time, you know, so they're either going to play the role of president or vice president, but it would be difficult to assume both roles at the same time. So order is important. When somebody's selected as the president, then that person is not going to be considered, for example, for the vice president. So order is important. Also, when you're awarding prizes, first, second, and third prizes or places, for example, scheduling or itineraries, when you're constructing numbers or IDs or words. So this is keywords for when order is important. And then you have keywords also when repetition is not allowed. Okay, so people being seated in a row, lining up. Hands of cards, okay. Subsets, committees, repetitions not allowed. And then and then of course if they indicate that repetition is not allowed, then you'd have to follow that. So these are, when you see these keywords in your problems, that can make a note that repetition is not allowed. Okay, so you can have these sheets out of that will help you for some of the problems that will involve either a combination or permutation or the fundamental counting principle. Okay, and the other sheet that you want to have out is this sheet, formula sheet, and so we're not going to have to do these by hand. We're going to use the scientific calculator to help us with that. So at least for the permutations and for the combinations, okay? But this one, when we use this problem, duplicated items, permutations, you will want to do this using the formula, you do need this formula, and then you'll do your substitution. So there's a problem I'm going to show you on the review for that. Okay, and then these theoretical probabilities, these are like when you're working with cards, or you're working with die, rolling one die or two die, and you have in the numerator your outcomes over your denominator, your total possible outcomes. So that down here I have the cards laid out, your 52 cards, and notice how you have these different suits, your hearts, your diamonds, these are your spades and your clubs. Okay, and notice on the numbering there is no one, there is no card that begins with one. The cards, you know, go really in numbering from 2 through 10. These are called face cards. These are your face cards: jack, queen, and king. And this is separate. This is not considered a face card. This is the ace card. And so we'll just treat the ace. I know in some games they have numberings assigned for the ace cards, but we won't do that unless we're told in the story problem, which generally doesn't happen in our probability problems. Like in the games, we don't assign usually ace a number. We just call it the ace card. Okay, and then you have your sample space here for rolling two dice. And so when this, you know, like for example, this die right here, when it rolls, and so one of your dies is lying, uh, you know, and I actually have a couple of dice here. The 4-3 would mean that one die, the first one, is landing on a 4, and then the other one is landing on a 3. So that's what the 4-3 represents. Okay. And so 2-3 means that one of them lands on a 2 and then the other one lands on a 3. That's what 2-3 means. Okay. Whereas if you see a 3-2, let me see, if we see a 3-2, which right here, that would be a little bit different, because then the first die would land on the 3, and then 3-2, and then the second die would land on a 2. Yeah, so 3-2 is different from the 2-3 because they're just different dies. Okay, so one of them is assigned die 1, the other one's assigned die 2. Okay, all right. So those are examples of theoretical probability. We're dealing with cards or dies. Okay. Empirical probability, you generally have a table, and you're creating a probability base of numbers off of a table that you're reading. Okay. And then let's see, these two, I think probability of a combination, I think you had some homework problems with this set, but I don't think I put these on the test. So the one that deals with 8.5, section 8.5, the probability using the counting principle involving permutations and combinations. So I didn't put any like that from 8.5 on the test, because we already had permutations and combinations. 8.2 is permutations, 8.3 was combinations. And so I think you don't have to worry about where you could have in the numerator and denominator several permutations or several combinations. Okay. Then in the chapter 9 section, we have these formulas: the mean, this frequency mean when you have group distributions. You have like a weighted mean, the mid-range, and actually there should be some parentheses like here. You want to make sure you should have some parentheses there, and also here you should have some parentheses wrapped around that. So when I make a PDF of my notes, I will include this in it, but there should be some parentheses there as well. These have the parentheses here. Standard deviation. So these standard deviation, I did create a table for that, and I'm going to put that in your on your test. So these I'll show you how to do this on the calculator, but then I want you to also to use your table, and I'll make it short. Like this is too long. This has I think 12, because one of your homework problems has in your review has 12 data values: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be too long for test purposes. So it'll be shorter, and then also there'll be some repetition. It's a little bit easier when the data values repeat, because then you're repeating some of the information in your rows, and so that's how we kind of have that set up to save a little bit of time on a test, but yet you're still filling out your table. Okay, and so oh, this is also the class width, lower class limit minus previous lower class limit. Okay, and your range, which we use the range here, the mid-range, which is divided by 2. Okay, so you want to have this formula out so you can use that while you're taking your test, and then of course your calculator. Okay, all right, so we said 1 was D. Okay, and then 2, this is just to make sure we know how to use the calculator. So for 2, they want you to use the formula for NPR to evaluate the following. And so we've got the 6 here. N is 6, permutation, and R is 3. So just to type that in on a calculator, what you would do is you would want to first, you should first type the N value, which is 6, in your calculator. Okay, so I'll turn this on. Okay, and then I'm going to type 6. Okay, and then you're going to press the probability key. See right here, PRB. So you're going to press the probability key. Okay, so I'll write that down. Okay, and since we want the permutation, it's already highlighted, and so you just, it's already highlighted. So you're going to just press the enter button. Okay, and then now that you have that, now you're going to go ahead and type your R. So now you're going to type your R value, which is 3. Okay, and then you're going to press enter. Okay, and so when you have an application problem and you're setting these up, your N value should always be your larger value. You'll see that that you will not get a result or valid result. You know, these results have to be right at least 1. And so if I were to type it wrong backwards, if I were to type in 3, let me just show you what it gives us, and then probability, and then number 1, and then 6, enter. See how I get 0? Okay, and so you know you would need to have at least, right, at least 1. Even if I were to do, let's see, 3, probability 3, yeah, that gives you 6. Okay, let me do 3 and probability 0. Yeah, even that would give you, see, at least 1 on that. Okay, and so And so when you do these, the n value is going to be your larger value. Okay, so that might help you remember type n value 6, which is always the larger. Okay, so that way if you have an application, you're wondering if you set that up right, remember n will always be your larger value. That might help you. Okay. Okay, so then for number 3, we have a combination. Okay, and they want us to do 7, right? N is 7 combination and R is 4. Okay, so here we would type N value 7, which is, the larger value. Then you're going to press your probability key on your calculator. Okay, so let me clear this. Let me do that. So type 7, probability key. And now here you want to go down to number 2 because we're going to do a combination. So you see this little arrow here? So you tab down to number 2. So I'm going to say and tab down. So you have these little keys here. Tab down to number 2, which is NCR. Okay, and then press enter. Okay, and then you're going to type your R value, which is 4. And then you're going to press enter. And you get 35. Okay. Okay, so now let's go to number 4. So we have here that a restaurant offers the following limited lunch menu. So we have some items choices for the main courses, some item choices for the vegetables, beverages, and desserts. If one item is selected from each of the 4 groups, in how many ways can a meal be ordered? Okay, and so here this is a variation of the fundamental counting principle. And so when I set this up, I'm going to put F, let me write it down, fundamental counting principle. And I'm going to put 4 blanks here. Okay. And so, so the first one is the main courses. And notice how you have 3 choices, the ham, the chicken, and the fish. Okay, so I'm going to put 3 here, 3 choices. So I'm going to put main course choices. Okay, and then you have vegetables. Okay, so you have 2 choices, 1, 2, the corn and the green beans. So vegetable choices. Okay, then you have beverage choices. So you have 3 choices: coffee, tea, or milk. And then you have your dessert choices: cake, pie, or sherbet. So you have 3 choices. Okay. All right. And then you would just multiply those items then. You would multiply those items. So I have here 3 times 2 times 3 times 3, and there's your 54. Okay. And if you want, because we could look at the chart and see, because FCP was on there, we could go back and look at that chart, FCP, and see if we gather anything from it. It says order or categories are important. And so, because we could consider these, categories, right? The main course, the vegetable, the beverages, the desserts. And then also it says you have a choice on repetition in an FCP problem. Either repetition could or not be allowed. And so, there was no need to address repetition here. They didn't say anything about anything repeating. So I just counted each item once. 1, 2, 3, 1, 2, 3, 1, 2, 3. This vegetable had 2 items, 1, 2 here. Okay. And then, and I guess if you go under order being important, I guess you could go under, categories. Well, only arrangement in the sense that you cannot mix, like if you're talking about a main course, you don't want to count a dessert in here, right? Here you're talking about main courses, so you do want to limit it to these choices. You don't want to put something other, some other category in the main course area. So just be careful when you're counting, when you count that up, okay? All right. Okay, and then number 5, license plates in a particular state display 4 letters followed by 4 numbers. Okay, how many different license plates can be manufactured for this state? Okay, so this is another idea of the fundamental counting principle. I'll put FCP here, FCP, another idea for that. And so again, I'm going to put, let's see, 4 letters. Okay, and the letters of the alphabet are A through Z, and there are 26 letters of the alphabet. So these are A through Z. So yeah, so this actually 26 goes here. And it didn't say anything, like it didn't say repetition is not allowed. Didn't say anything about uh, repetition is not allowed. See, it says if it's indicated, repetition is not allowed. So if it says that it's not allowed, then you assume that. But if it doesn't say anything about repetition, then you assume that you can have an A here and you can have an A here. As long as it doesn't say that quotation, repetition is not allowed, you assume that, you could have an A here, you can have another A here. You assume that, okay? So we're assuming repetition is already okay, it's allowed, since they didn't make that comment. Okay, so 4 of them are letters, and then 4 of them are numbers. So with the numbers start with 0 all the way through 9. Yeah, not 10, because 10, to make 10 you need two markings here. So that's why it's 0 through 9. So it's a one-digit number. And so there are 10 of them. There's a total of 10 of those. Okay, so I'm going to spell out 10 here actually. So you have the 1 through 9, and then you have that 0, which counts as 10 digits. So I'm going to put 10 here. Okay, so these are numbers. And again, it doesn't say repetition is not allowed, so we assume it's okay for them to repeat then. Yeah. So then if I multiply that out, let's multiply that out. So what I can do is I can also use my exponent key, so I can say that this is 26 to the 4th power times 10 to the 4th power. I can say that, okay? And I'm using my hat key. So let's see right here. See this hat key here? So I have 26 hat key or caret key to the 4th. Okay, but then I have to push it down. See that? Yeah, so this is fine. Push that down. And then times 10 raised to the 4th power. And then here I could hit enter because I'm not typing any. It's okay if this is floating up here, this cursor, because you're not typing anything else. So I can hit enter. Okay, and then I should get, this should match this. Let's see. Yes, it matches. So 100,000 million, that's like in the billions, right? 4,569,760,000. Okay. Okay. Okay, so let's try that again. So let's see. So I have 26, then the caret key to the 4th power, and then you do have to push that down. So you hit this side arrow here, and then you have 10 raised to the 4th power. Yeah, so here I didn't do times. Let's see, and I should get, let's see if I get the same thing. Yes. So I didn't have to put times as long, but I do have to push it down. Do have to push that down. See, if I don't push it down, 26 raised to the 4th power, and let's say I don't push it down, and then I say times 10 raised to the 4th power, and then hit enter. Oh, overflow. See, overflow error. Yeah, so you need to make sure that you can't have that. So let me clear that. So you need to do 26, or you can do 26 times 26 times 26 times 26 times 10 times 10 times 10 times 10, and we get the same thing. Okay, so just practice that. So you want to make use of the when you do that 26 to the 4th power right here, you want to make sure that you use in your arrows, you want to make sure you use this arrow. So the right arrow to bring the cursor down. And why would that be that? For the input of 10 to the 4th. Okay. Right. Okay, so now let's look at number 6. So a club with 8 members is to choose 3 officers, okay? A president, a vice president, and a secretary who's also, they played 2 roles, secretary and treasurer, but that's allowed here because it's set up that way in the title, secretary, treasurer. So that's here, this is allowed, okay? If each office is to be held by one person, and no person can hold more than one office, and how many ways can those offices be filled? Okay, great. So, and they don't necessarily always have to say that. Usually that's implied, and that goes back to your, let's see, if we look at that chart, see, you're talking about election of officers, that order is important. So let me write that down. Okay, so election of officers means order is important. Okay, and then if I go back to this chart, I think this is the one I was saying, those 3 charts are similar. This is probably the best one to use because of the wording that's down here. But if you look at order being important, see how they have that here? Order is important. Yes, I would make use of the permutation for that. Order being important. Okay. And it does say over here also repetition not allowed. Yeah, and they're saying that one person and no person can hold more than one office. Yeah, so that kind of nails that or seals that in. And so we're going to use permutation. Okay, so in your permutations, you have this NPR. Okay. Okay, so for us, our N is going to be our larger value, and those are the available. That's going to be the available group. Okay, so you have 8 people available to choose from, and then R is, yes, it's a smaller value, and it's also the selected. That is the number or the amount selected, and we're choosing 3 officers. Okay. All right, so then I'm going to go to my calculator, and I'm going to type 8. Okay, and then go to probability, and I want to hit number 1. I want enter, so I want to hit enter. Okay, and I'm going to type 3 and then hit enter. Okay, and I should get 300, see, and 36. Okay. Okay, so let's go to the next problem. Okay, so 7. So determine whether the statement is true or false. Okay, so 5 factorial is equal to 5 plus 4 plus 3 plus 2 plus 1. No, that's not correct. factorial is a product, so it is choice B. So this is false, and it is choice B. 5 times 4 times 3 times 2 times 1. Okay, and so the way you use that on your calculator, factorial. Let me show you where factorial is at. You would type 5 on your calculator. You would also press the PRB key. Okay, and then you want to scroll down. So you want to tab down. So you have these keys. So you want to tab down to number 3, which is the factorial. Okay, so I'm going to highlight this. And then hit enter. Okay. And then you're going to have to press enter again. Okay, and you get 120. Okay, so that was 5 probability. Tab down, hit enter, double check that, and then hit enter again. Can you get 120? So 5 factorial is equal, yes, it does equal 5 times 4 times 3 times 2 times 1, and that gives us 120. Okay. Okay, let me also check, let's see. So, another way of it, this isn't an application, but also we wanted to put an application to that. Let's say a nurse has 5 patients that she wants to see, or he or she, the nurse, wants to see, and how many ways can they see those 5 different patients. So once this is how you could use a 5 factorial. So let's say that they have a patient in, let's just say, if there's, let's say there's 5 rooms, a patient in each room, 1, 2, 3, 4, 5. So the nurse, once she sees that patient in room 5, then she's only going to see them one time during that day, let's say, or that time period. So then once she sees that patient, right, then she goes on to the next patient, who's like in room 4, let's say. So then she would see that patient next. Okay. And after she sees that patient 4, then she goes down to another patient, right? And then you could also assign, like, if you assign names to them. So maybe she sees Mary first, and then John, and then Victoria, right? And then now she's down to 2 patients. So she'll see Richard next, and then last Vivian, let's say. So that could be another way how you could use a factorial problem there. So I was trying to think of a situation. So just different ways to see a patient. Okay. If you have a total of five patients. Okay. So what are the different ways that you could go about seeing them in that order for the day? Okay, so that would be an example of factorial 5 down to 4 down to 3 down to 2 down to that last patient. Okay, so because this one doesn't have an application applied to it, but that's kind of what an application problem would look like. Okay, all right, number 8. In how many distinct ways can the letters of the word defenseless be arranged? Okay, so here, this is the one where you want to use this formula here, this duplicated items permutations. This one, duplicated items permutations. So use duplicated items permutations formula, okay, which is P is equal to n factorial over parentheses P factorial times Q factorial times R factorial. And if there are other letters that repeat repetitively, then that's why they do dot dot dot, and then you want to close, very important, close the parenthesis. Okay, but this is the format you need to use for that. So you should write down the formula of this word test problem, write down the formula on your paper, and then what you have to do is you have to kind of make a list. You have to make a list of all uh, the count. You wanna make a a list of the count of, like they said, duplicated variables. They say items, but they're variables. Okay, so we have in the word defenseless, you have D. Okay, and how many D's do you have? Just one. One letter D present. Okay. Okay, then you have E. So how many times does E show up? So there's 1, 2, 3, 4. So letter four letter E's, or 4 letters. I'm going to say 4 letters, but 4 letters that are E's. Okay. Okay, after E you have F. So you just have one F, one letter F present. Okay, then we already talked about the E's. Okay, we have an N. So how many N's do you see? Just one letter N present. Okay, then I have S. So how many S's do we have? 1, 2, 3. So 3 letters that have S. Okay, we already talked about E, L. 1 letter L present. We already talked about E, we already talked about S. Okay. Okay, so then what's your total? So if I have my total, I have 4, 5, 6, 7, 8, 9, 10, 11. I have a total of 11. And you can always just double check on your calculator. 1 plus 4 plus 1 plus 1 plus 3 plus 1, 11 letters total. Okay, so this is in your formula, this is your n factorial then. Okay, so then you can substitute. And what you should also do is go back and check that we had 11. You should go back over here and double check and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, you're gonna need to make sure that's correct. So I have 11 factorial over, and now here, now you only need to list these like the duplicating variables. You don't have to do it for 1 because the value of 1 factorial is 1. Watch. 1 probability factorial is 1. So since 1 factorial equals 1, okay, then we don't need to include 1 factorial in the denominator. We don't. You don't need to include because the value 1 factorial is 1, and 1 times anything is that anything, so you don't need that 1. But anything else that repeats, we do need that. So see, like this 4, each comes up or shows up 4 times, so you need parentheses 4 factorial, and then it's times, right, times, and then you need this, see this s 3 times, you do need that 3 factorial. But then that's it. That's it. And we already used 11 was a total. 11 goes in the numerator. Okay. All right, so you need to type that in, and you do need the parentheses. So I do have the parentheses. I did write those in. You do need them. I believe if you don't put them in, you will well, I tell you what, if you use this key, if you use this key, then I think it's okay if you don't use parentheses if you use this key, but if you don't use that key, then you need them. So let's try with that key first. So let's make use of let's use the N over D key, so that you have that set up. Again, if it's slanted, it's not set up, it's because under mode you want that math print. So under mode you want math print, and that will give you, when you do that, when you hit ND, that will give you this key like that. Okay, so then you're going to type 11 and then the factorial, so probability, and then number 3, and hit enter. Okay, and then just hit this down arrow. Okay, and then you're going to do 4 factorial, 4 probability, 3, enter, and then you don't have to hit times. You can if you want to, but you don't have to. It's implied. If you hit 3 and then probability factorial, see, and then you hit enter, and that gives you 277,200, which is what we have here. Okay. Okay, so again, I'll do that again, and if you want to put the times, you can. So I have 11 probability factorial, and then press this arrow down, and then I can do 4 probability factorial times 3 probability factorial, and then hit enter. Okay. So if you don't use that N over D key, then let's see, if you don't use it and you're just doing it horizontally straight across, so you have 11 probability factorial divided by, and then here you do need the parentheses, divided by 4 probability factorial, and then 3 probability factorial, and then close the parentheses, and you do get the same answer. If you don't put the parentheses, you won't get the same answer. Let me show you that. So if you do 11 probability factorial divided by, let's say I don't put the parentheses, then I do 4 factorial times 3 factorial equals, yeah, see how I got something different? So yeah, if you're going to type it horizontally, then you do need the parentheses, okay? If you're going to type it horizontally. So use this key, okay? And then if you don't use that key, I guess I can say here, include parentheses in denominator if inputted, like if you type it into the calculator, if input it horizontally. Okay, but if you make use of this key, then you saw how I didn't have to put the parentheses in them, okay? All right. Okay, so remember how to show your work on that, okay? So you keep track of your lists, your formula, your substitutions, okay? All right, let's see, 9. So let's see. So 9 says that of 19 possible books, you plan to take 8 of them with you on vacation. How many different collection of 8 books can you take? Okay, so here we're going to use a combination on this, and so order's not important, doesn't matter. You just want to get 8 books, doesn't matter how you pick them. And so I'm going to use a combination. See, he doesn't say anything about order being important. See, oh, right here, order non-important, okay, for a combination. Okay, and then it says repetition not allowed. Yeah, and we're assuming if repetition, um, yeah, we're just taking 8 books with us. Yeah, so yeah, you have 8. You're picking 8 books, so you do need 8 books. If you repeat some of the books, then you won't. Then you won't. Why would you want to take the same book with you, right? The same book twice. So we're not going to have to deal with the repetition on here, okay? But we do want a combination. Okay, so I can write here order not important. I'm using NCR. Okay, so remember the larger value goes or a larger value goes first. Okay, and the larger value is 19. So this is equal to 19 books available. Let me actually write that over here. So 19 books available, and we're taking eight books selected. Okay. Yeah, so write down the formula. So or just this, this is what I mean by write down the formula. So write this down here. So you don't have to write this. We're not doing this part by hand. We're using a calculator, but you should write that and then do your substitutions. And then when you type that in, you want to type 19 probability, and you want to go down to number 2. Also, if you don't want to go down to 2, you can just hit 2. So I'll do that in a little bit. Okay, and then hit enter, and then type 8, and then enter. Okay, so that should match. That matches, okay? Okay, so again, so I'm typing 19 probability, and then I was going to hit number 2. So let me try it again. 19 probability, and then you can either tab down, or you can just hit number 2. If I hit number 2, look what happens. See how that takes you to that? And then you were taking 8 books with you, and then hit enter. Okay. Okay, so in how many ways can a committee of 3 men and 4 women be formed from a group of 9 men and 12 women? Okay. And in your committees, repetition is not allowed in a committee. If I go back to my keywords, when repetition is not allowed, see on committees, let me write that down. So repetition in committees. Excuse me. And I'm also going to say that so for repetition not to be allowed, we're going to use the combination. So that's one of the requirements here. Combination required, repetition not allowed. Okay, now so I know the reason why we're not going to do permutation, see that has required also, is because also the order here is not important. So you just want 3 men and 4 women. And so the order in which you pick those 3 men and 4 women is not important. Okay, you just need to make sure you have 3 men and 4 women. So, but other than that, order is not important. So you just need 3 men and 4 women. Now, and so here, when in your combination, we're going to use NCR. Okay, so we're going to have, if we do the men first, 9 men. Okay, so 9 combination, and you're choosing 3. Okay, so these are the men. Okay, now here you're going to do times, and then now the women, 4 women are going to be selected from 12 women. Okay. Okay. Okay, so now if I use my calculator on that, so I have 9 probability, tap down, or you can hit number 2 combination, and then 3. Okay, and I am going to do times here, times, and then 12 probability combination. You can do number 2 or tap down to 4, and then hit enter. Excuse me. And that does match 41,580. It does match. And remember your comma, 1, 2, 3, comma. Okay. Now I'm gonna go back without the times, and I know that you're gonna get the right answer. Let me show you. So 9 probability NCR 3, and then let's say I just do 12. See, that's not gonna work. See, that's like becomes 312. Yeah, so it's not gonna like that. I know already. So probability 4. Yeah. So when you get 0, you know that's a hint that there's a typo, right? There's some kind of an error there. You need to have at least 1. Okay. All right. Okay. Okay. We'll go to 11. So let's say a 12-sided die is rolled, and the set of equally likely outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, all these different faces, sides, faces. Find the probability of rolling a number less than 11. Okay, so it looks like this. Probability that your x is less than 11. Okay, this is the symbol for less than. It didn't say less than or equal to. Okay, this is less than or equal to, and it didn't say less than or equal to. It just said less than. So you need to pay attention to the vocabulary. And so for us, less than 11 would be all of these right here, all of these right here. These faces that are less than 11 would be those. So you would have, and your formulas, what we could use is, this is an example of a theoretical probability. Anytime you're working with dice or cards, it's theoretical probability. Anytime you have a table, you're reading things from a table, that's empirical probability. So this is theoretical probability. You write that down here. So I'm going to put here number of outcomes over total possible outcomes. So for us, the number of outcomes would be 11. Let's see, probably that it's less than 11. Oh, okay. So actually, sorry, I made a mistake. Actually, I don't want to include at 11. It's less than 11. It didn't say less than or equal to 11. It's less than 11. So I'm going to highlight those. Okay. So that'd be 10. 1 through 10. And notice how it doesn't start off with 0 either. In your dice, it would have 12-sided die that have one dot, or 2 dots, right? 3 dots. Okay. So they don't have a side that's empty. So it's 10 over the total, which would be 12 sides. And then always reduce. So I'm going to reduce by 2. So 2 goes into 10 5 times, and 2 goes into 12 6 times. Okay. So that's 5 6. Okay. All right. So these are even numbers, so you want to reduce. 2 goes into both of them, and you get 5 6. Okay. Okay, so get 12. Fill in the blank so that the resulting statement is true. So standard bridge deck has blank cards with 4 suits. Okay, so we have 52 cards. So that's important. If you're working a theoretical problem with cards, you want to know how many total cards are in a deck. 52 with 4 suits. Okay. Okay, so here are your choices. I didn't see here are your choices. So with 4 suits, so this is spades and hearts and clubs or diamonds are red. Which ones are red? Okay, so the red ones are the hearts are red and the diamonds are red. Okay, so right here is why the hearts and then the diamonds are red. And then the ones that are black cards are these, the clubs, or these are the clubs, and then the spades. These are called spades, and these are clubs. If it has like these 3 leaves, has a club. So let's see what they have here. Those are the black ones. So your choices on number 4, they have hearts. No, we know hearts are red, or clubs. And clubs, see if I can draw a club. Kind of like a leaf. And then the spades. Okay. So you want to be familiar with your cards, okay? Okay, so let's go to 13. So you randomly select one card from a deck of 52. Okay, good. So they didn't have to tell you 52. If it's a normal deck, you have to know it's 52. Okay. And then you want to find the probability of selecting a, a black 5 or a red 3. Okay, so this is an example of a theoretical probability. And you're finding the probability that you have a black 5 or a red 3. Okay, and we have from theoretical probability, number of outcomes over total possible outcomes. So number of outcomes over total possible outcomes. All right. And then also the word or means union. Okay, union. So you're doing the black 5 card union with the red 3 card. Okay, so you want to do a union. Okay, so let's see. So the number of outcomes. So let's see. Let's make a list of our outcomes so we can count them. So we have a black 5 card. So here are my black cards. And I want a black 5 card. Okay, so it looks like I could have these, right? These two are 5. I cannot include these though because these are red. It said it had to be black. So I'm looking at the 5 of spades and the 5 of clubs. So I'm going to write that down. So 5 of spades and the 5 of the clubs. Okay. And then or means you're going to union that. So you're going to combine that with the red 3, the red 3. So I go to my reds and I want the 3. So I've got a heart that's got a 3 and a diamond. Yeah. So I've got a 3 that's got a heart and a 3 that's got a diamond. Yeah. But then that's it. That's it. And remember, union or is union. So yeah, you're gonna add all your outcomes. So the number of outcomes is 4. 1, 2, 3, 4. So 4 over your total possible outcomes. There's 52 cards in a deck. Okay. And then that can be reduced. There's even, so you can either reduce it by 2 or I think you can reduce that by 4. Let's see. So that's the greatest common divisor. Okay, so always let your teacher know what you're reducing by as part of showing your work. Okay, so 4 divided by 4 is 1. 52 divided by 4 is 13. So that reduces to 113. Okay. All right. So on a problem like this, to show your work, you should, in a card problem, you should list all your outcomes. And on the test, on your template, I'll probably have something like that. When I create my templates, I go back to how I showed my work, and I'll have like a list for the outcomes for you to put that on. Okay. And then you write your formula. You write your formula and then substitute and reduce fractions. Okay. And number 4, that's another theoretical probability, because it's dealing also with dies. So single die is rolled twice. The 36 equally, yeah, so there is 36. If you count 1, 2, 3, 4, 5, 6, so 6, 12, 18, 24, 30, 36. Yeah, so there's a total of 36. Just like the cards has 52, these outcomes for rolling two dice, first row, second row, is 36. That's your denominator. Find the probability of getting two numbers whose sum is less than 7. Sum is less than 7. Okay. All right. So less than 7. So let's look at our outcomes. So again, it did, just like I said earlier, it didn't say less than or equal to, it just said less than. So, and when we set this up, we want probability that our sum is less than 7, okay? And it's going to be the number of outcomes over total possible outcomes. Okay, and so it said less than 7. So remember that they haven't said anything about greater than, but this symbol means greater than. This symbol means greater than or equal to. Okay, so like, so an example greater than would be greater than, like, let's say I have, I'm just making this up, so like, you know, 15, right? 15 is greater than 3. You always read these from left to right, left to right. So 15 is greater than 3, right? So this is greater than symbol, okay? Of course, you can always draw Pac-Man, right? You know, Pac-Man chomps on the larger number. The way they win in gaming is you want more points. The most points is the winner. So you can always draw Pac-Man will chomp on the larger number. So this is your, to confirm that, greater than. Okay. So that's just in case you have some greater than, because we saw less than the other problems, but I haven't mentioned anything about greater than, so I'm going to do that now. Okay, so going back to us, we want outcomes for some less than 7. It didn't say less than or equal to 7, it said less than 7. So if I start here, 1 and 1, yeah, 1 plus 1 is 2. Okay, and then if I look at 1 and 2, 1 plus 2 equals 3. 1 and 3, 1 plus 3 equals 4. 1, oops, 1 and 4. 1 plus 4 equals 5. 1 and 5. 1 plus 5 equals 6. But then I have to stop there because 1 and 6 is 7, so I can't include that one because I went less than 7. Okay, so I go to the second row, so that's from the first row. So now I go to the second row. I can change my ink. So then I go to 2. 2, 1. 2 plus 1 equals 3. 2, 2, because 2 plus 2 equals 4. 2, 3, because 2 plus 3 equals 5. 2, 4, because 2 plus 4 equals 6. But then I'll have to stop there because 2 and 5 is 7, and it has to be less than 7. So I go to the third row now. I can change my ink. So 3. So 3, 1, because 3 plus 1 equals 4. 3, 2, because 3 plus 2 equals 5. 3, 3, because 3 plus 3 equals 6. But then I have to stop there because 3 and 4 gives me 7. So I want less than 7. Okay, so now I go to 4. Go to 4. So 4, 1. 4 plus 1 equals 5. 4, 2. 4 plus 2 equals 6. But then I have to stop there because 4 and 3 is 7. It has to be less than 7. Okay, so now I go to 5. 5, 1. 5 plus 1 equals 6. I have to stop there because 5 and 2 is 7. It has to be less than 7. And I can't do anything from this last row. 6 and 1. 6 and 1 is 7. It has to be less than 7. So see, these are all bigger. 6 plus 2. 6 plus 3 is 9. So I want a sum. A sum. They said a sum that's less than 7. So if I count all my outcomes, just count, starting with this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, it looks like we have a total of 15 over, remember, 36. And that can be reduced by what? By 3? Greatest common divisor by 3. So 15 divided by 3, right, is 5. And 36 divided by 3 is 12. Okay, and that should match what we had over here. Let's see. Okay. Okay, let's go to number 15. So a professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown in the following. Group frequency distribution. What's the class width? Okay, so the class width is this formula here. Lower class limit minus previous lower class limit. Excuse me. Okay, so you see that in this table here, see the number of interactions, see these ranges here, okay, and these frequencies. So all of this right here, all these are the lower class limits. So we abbreviated LCL minus previous LCL. Okay, so these right here, these are LCLs, lower class, or these are upper class limits. Okay, so lower class limits, these are upper class limits. Okay, so on the formula we also could have said upper class limit minus previous upper class limit. We could have done that too, but I just stuck with the lower class limits. Lower class limit minus previous lower class limit. So if I look at, for example, 53, it would be 53 minus 45, see? So if I do that, 53 minus 45, it gives me 8, okay? Let me see, that's what they have there, okay? So, and you can check, you could do any pair, you could have done, or you could have done um, 61 minus 53, 61 minus 53, see that's 8. Or you could have done 69 minus 61, that's 8. Or you could have done 77 minus 69, okay? Or you could have done that last one, 117 minus 109, and you're going to get 8 for those, okay? So those are your widths, your widths. Okay, so these are just the frequencies. We don't have the actual data, but apparently there were 11 data values that they fell within this range between 45 and 52. Okay. Okay, so that's what they want. They want the class width. Okay, that's how you find that. Okay, it's 15. Okay, now we're going to look at 16. Let's see. So I'm gonna just get a drink of water, and I'll be right back. Okay, so I'm going to do this just for a second. I'll be right back. All right, class, I'm back. All right, so let's see. So let's take a look at what 16 says. So as of 2011, the following are the ages at which a country's presidents were inaugurated. So they're the ages of presidents then, okay. Construct a group frequency distribution for the data. Use 41 through 45 for the first class, and then use the same width for each subsequent class. Okay, and the good thing is it looks like they set up the other subsequent classes, but if I were just to check the width, length, I would do lower class limit minus previous lower class limit. So this would be 46 minus 41, which is 5. Okay, and each width should be 5. So if I were to check, for example, using the last two classes, 66 minus 61 is 5. Okay, and they should all be 5. When you do that kind of subtraction, they should all give you 5. Okay, on both sides, even on the upper side, 70 minus 65 is 5. Okay, 65 minus 60 is 5. Okay, all right. Okay, now what I've done is I went ahead, normally we just don't go straight to the frequencies. If you remember in your MyLabs Plus videos and showings, they normally do a tally. They do a tally first. They do the tally and then they count the tick marks, the tallies, and then they get the frequency for that. Okay. And then also what we probably should do would be helpful is if we were to probably even, put the data in some kind of order too, that would probably be helpful if we could do that as well. Let's see. Well, actually, no. Actually, let's see. No, we'll be okay here because of if we were doing a stem and leaf plot, I would first put the data in order. But when that will be coming up in the next problem, we're doing a stem and leaf plot, then I would put the data in order. But actually, for this one, I will do a tally though, instead of just going straight to the frequency, and I'll just start with the first data value, which is 52. So you want to ask yourself which class does 52 fit into? So 52 at the age of the president 52 would be this class. So this is the first class. This is the first class, the second class, third class, fourth class, fifth class, and there are 6 of them. 6th class. Okay, so if I look at 52, 52 fits under the third class. So put a tally there. 56 fits into the fourth class. 49 fits into the second class. 68 fits into the sixth class. 43 falls into the first class. 55 falls into the third class. 51 falls into the third class. 55 also falls into the third class. 49 falls into the second class. 55 into the third class. Now you see that's already 1, 2, 3, 4. So then the fifth one goes this way. It's 1, 2, 3, 4, 5. So the fifth one goes across. Okay. 62 falls into the fifth class. 58 falls into the fourth class. 49 falls into the second class. 67 falls into the sixth class. 63 falls into the fifth class. 64 falls into the fifth class. 69 falls into the sixth class. 68 falls into the sixth class. Okay, here we go. 44 falls into the first class. 53 into the third class. 51 third class. 65 fifth class. 56 fourth class. 44 first class. 46 fits into the second class. 52 falls into the third class. 59, okay, that's an age that falls into the fourth class. If somebody's 59, they're going to fit in between the 56 to 60 range. 53, third class. 66, sixth class. So that's 1, 2, 3, 4, 5. Okay. 42, first class. 54, third class. 42, first class. 68, last one. 48, second one. 63, fifth one. 60, fourth one. Okay, so now we just need this last row here. 43, first one. 52, third one. 61, fifth one. 49, second one. 53, third one. 43, first one. 49, second one. And then 59, fourth one. Okay. Okay, and then we go back and we count, and if I didn't make a mistake, then we should match these counts here. So let's see. So 5, 6, 7 frequency. So yeah, that matches that. 5, 6, 7. Yep, that matches that. 5, 10, 11, 12. Okay, good. That matches. 5, 6. Yes, that matches. 5, 6. And then 5, 6. Okay. All right. So that was 16. Okay. So again, you're just trying to see with each data value which range does it best fit under. Well, with that age falls within a range, okay? And then of course in the range it does include the endpoints. This does include to 41 to 45. If a number is 40, if an age is 41 or 45, it does fit. It does include that endpoint, okay? Okay, let's look at 17 now. So a random sample of 40 college professors is selected from all professors at a university. The following list gives their ages. Construct a stem and leaf plot for the data. Complete parts A and B. So part A is determine the leaves for each corresponding stem. Complete the table below. And then they want you to answer information about your stem and leaf plot. Okay. And it does say that under your leaves, it does want them in ascending order. So ascending means from smallest to largest order. Okay. So I think and all these have these, you know, the stems are already created, but usually we use the idea of n minus 1 equals the number of digits in our stem. And you can see in our stem that you only have one digit. And that's because n stands for the like your number of digits in your data. So this has two, right? Two digits in your data. So this is two. All these have two digits in our data. So n is 2 because it's the number of digits in our data minus 1. And 2 minus 1 is just 1. So that's one number in your stem. Okay. So here they started the stem with 2, like in our 20s, right? They didn't start with 1. We didn't, or 0, because we didn't have any like teens, 10, 11, 12, 13, 14, 15. We didn't have any teens. We started in our 20s with our smallest data value. And also we didn't have any preteens like 1, 2, 3, 4, 5, 6. So that's why we didn't need a stem of 0 or 1. We started with stem of 2 for that reason. And what I'll go ahead and do is if I go ahead and arrange the data in order, beginning with 20s. Okay, so if I do that, if I go through and I look for all my 20s, so let's see, any 20s here? I have a 120 here. Okay. So I can highlight that once I use it. So, okay, how about here? Any 20s towards a 25? And a 22. And then the third row looks like we have a 28. Yeah. And if that's all the 20s we have, then when we come over here and see all these, see 2, 2, 2, 2, that's your stem of 2. And then these are your leaves. That's a leaf. 5 is a leaf. 2 is a leaf. 8 is a leaf. And then we're going to put the leaves from smallest to largest. So we have 0, 32. No commas. They don't. The computer, you see when you do your homework, the computer I don't think doesn't have you put commas. So 0, 2, 5, and then 8. So we usually try to line them up. That way if you turn it to the side, then you can look at the silhouette of the data and you can look for peaks and tail ends. Okay. All right, so let's see. So for 3, if I start with 3, where's my highlighter? So if I look at 3, I have 38. Next, 3 is 33, 35, 31, 32. Okay, last row. 33, 31, 35, 39. Oh, and I see I skipped one. Did you see how I skipped this 32? Excuse me, so I go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, looks like I got all 10 of them. Okay. Okay, so again, if I put it anywhere from smallest to largest, I don't have any 30s, but I have a couple of 31s. So see how I'm going to line these up like that. And I have a 32, couple of 32s. So I'm going to put 2 here because see, I already have the 3 there. So 32s. And then I have 2 33s. And then the 2 35s. And then a 38 and a 39. So let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I got all of them. Okay. Okay, then I'm going to go to the 40s. 44, 49, 48. 43, 49, 47, 48, 45, 48, another 49, and a 46. And at the bottom, I have 42 and 43. Okay. I feel like I have 13. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let me just go back and count, make sure. 13. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14. Okay, looks like I left one off. Let's see. Yeah, I left off this 42 right here, didn't I? After I did 43, 49, 42. Yeah, okay. Okay, so I got them all. So you want to double check. See that? Double check. Okay, in order from smallest to largest, I don't have any 40s, but I have a 42. And then I have two 43s. Oh, I have another 42. Okay, so let's see. I have two 42s, see that? And then two 43s. And then the 44. And a 45. And a 46. And a 47. And two 348s. And three 49s. Okay, we said 14, right? Yes, that's why I did just double check, double check. So 14, we said 14. Okay. Good night. All right, okay. Okay, now we're going to go into the 50s. So let's see. So I have 55 from the first row, 53 from the first row, 52 from the first row. Next, I have two 58s. And then the last one, I have a 51 in the last row. So it looks like I have 1, 2, 3, 4, 5, 6 data values that are in the 50s. 6 data values. Let's go back and check that. 1, 2, 3, 4, 5, 6. Yeah, 6 data values. Okay. So I start with, I don't have any 50s, but I have 51, 52, 53, 55, and two 58s. Okay. Let me kind of check these. Let's see. So here's a 0258. Okay. 1122335589. Okay. 2233 4, 5, 6, 7, couple 3 8s. Okay, and 3 9s. Okay. And then the 50s. Okay, this look matching. Okay, so now I'm checking the 60s. So let's see what's left. 65, 69, 64. There's a 65, a 66, a 67. Okay, so 1, 2, 3, 4, 5, 6. 6 60s. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, good, good. And then you want to order from smallest to largest. So a 64, 2 65s, 66, 67, 69. Good, that does check out. Okay, good. So now we need to answer some questions about the data. So it says, what does the shape of the display reveal about the ages of the professors? What does the shape of the display reveal about the ages of the professors? Okay. Well, and sometimes, we were saying you could draw the silhouette of your data and see this right here. See this longest? This is your peak right here. This is the longest. This is your peak. That's your peak. It's the most data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's your peak, 14. And so in your choices, it says that it would be that the greatest number of college professors are in their 40s, because this is the one that had the most age, their peak. Okay, so, and then just also talking about ages, the smallest, let me just put this down, the smallest data value would be the 20, and the largest data value, so let me highlight that, the smallest data value would be 20, and the largest data value would be 60, 60, what is that, 9, 69. So it's true, the greatest number of college professors are in their 40s, because this is the longest, see, it's the longest, 14 peak. But the smallest data value is 20, and the largest data value is 69. Okay? Right. Okay. So I'm going to pause this. This concludes like the probability section. So I'm going to pause the video so it's not super long, and then when it processes, I'll make it available in the modules, and then when I come back and do the second part of the video, it'll be to work 18 through 25, which is the chapter 9 information. But this I well, I'm not sure, the stem and leaf plot. Stem and leaf plot might have been some of chapter 9 actually. I think that was in 9.1 actually. This was part of 9.1. But I'm going to go ahead and stop the video here so it can start processing. That way it won't take so long to process. Okay, and then I'll momentarily start, after I take a little break, the second part to finish 18 through 20. Okay? Okay, see you in a bit.